Let's talk about using logic in MaxMSP. If you've never worked with logic in computers before, this can feel a little intimidating at first. But basically, we're just running some really simple tests to see if a condition is true or false. If something is true, it's going to output a 1. If it's false, it will output a 0. Why do we care though? Well, this makes it really, really easy to automate things. If you check to see if the volume goes above 6 dB, maybe automatically turn on reverb. If the incoming MIDI value is above 80, then apply a low-pass filter to the end of the synth. This might not be immediately applicable, but I guarantee that the more you program in MaxMSP, the more you're going to reach for these objects. So let's take a look. The most common ones you're going to see are the good old less than, greater than, and their variants, less than or equal to, and greater than or equal to. And these are really, really simple. The way that they work is that they take two values and then they output the results. So let's create some messages. And let's create a couple of test conditions. We're just going to use some integers here. Of course, you can always make these into floating points by initializing them with a decimal. And in this case, a 0 point will work nicely. But again, they're just testing the two types of values that you input. So we'll start off with an int and another. And I'm just going to connect these up. So this will be my testing condition. And this will be the value to be tested. Okay, so let's set this pretty low. Let's do 2. And we're going to go to 1. So is 1 less than 2? Yes. Is it less than or equal to 2? Yeah. Is it greater than 2? No. Is it greater than or equal to 2? No. And that's all it's going to give me. If I go to 2, I'll see that yes, it is less than or equal to 2, and it's greater than or equal to 2, but it's neither less than 2 or greater than 2. It is in fact equal to 2. So just a really, really basic bit of logic. But what if I want to test and see if something's exactly equal to something? Well, fortunately, there's a really easy one that I can do. I'll just move these over, and we'll take a little change. That is equal with two equals signs. And then to test if something is not equal, I use the exclamation point followed by equal. We'll connect those back up. And I'll move that over. Okay, so our condition again is 2. We'll go back to 0. So, is 0 less than 2? Yes. Less than or equal to 2? Yes. Is 0 greater than 2 or greater than or equal to 2? No. Is 0 equal to 2? No. Is 0 not equal to 2? Yes. 1. If I move this up to 1, we see changes in that, yeah, 1 is definitely going to be less than and equal to 2. Not greater than or equal to 2. Not equal to, but it is not equal to. Then if I go to 2, we have some changes. So obviously 2 is not less than 2, it's not greater than 2, but it is less than or equal to, or greater than and equal to itself. But here's the interesting one. I'm using that equals test. Does 2 equal 2? Yes. so it outputs a 1. So that allows us to test for specific values. I also have the not equal to, exclamation point equal. So it's saying, is 2 not equal to 2? No, it's failing that test. That's why it's outputting a 0. So again, all of this can sound very confusing at first, but the more you use this, the more you're going to see the value of using these for things like setting gates, automating the dry-wet of reverb or other effects, or just shutting off values from going through to your sound interface. There are 2 others that we should take a look at. These are a little bit more interesting, so we're going to come down here. And these are going to be OR and. So I'm using the pipe symbol. It's the 2 large lines. This is the logical OR. Create a message. And I'll drag that over. And then double ampersands is logical AND. So what does that mean? Well, logical OR compares 2 numbers and it outputs as true if either number is non-zero. And it outputs a 0 if both numbers are 0. So let's get 2 new integers down here. And we'll hook it up. And we'll set that to 0. So again, if either number is non-zero, it will output a 1. And if both numbers are 0, only both, then it outputs a 0. So I can increase that, and then if I increase this and it's not 0, then it's great. As long as one number is not 0, it's fine. This even goes into the negatives as well, because negative numbers are technically not 0. But if I go to have both numbers at 0, and set that, then it outputs a 0. Now, logical AND is another interesting little case here. Logical AND compares 2 numbers and outputs a 1 if both numbers are non-zero, and a 0 if either number is 0. So both numbers are not 0, so that's cool. One number is a 0, so it's outputting a 0. So these are logic tests that are really cool because they can give you a little bit more variety to test if one signal specifically is 0 or non-zero, or if both are non-zero, or if both are 0. For students in my music tech classes who have seen my Eurorack synth, this is a feature that I use with the sequencer a lot. It really lets you create some cool glitchy effects, especially when you're sending the combination of different gate states from the sequencer to different things simultaneously. It's very fun. These are conceptually kind of difficult to figure out how you're going to use them, but once you start to use them, they will quickly become favorite objects of yours.